In this lesson, we are going to apply the Pythagorean theorem with real-life situations to find missing measurements. We will also take a look at the longest space inside a three-dimensional rectangular cube. Jesse and Kyle began at the same location. Jesse ran 12 meters north while Kyle ran 18 meters east. How far apart are they from each other? So we're always going to create a sketch, and as you know, each of these will create a right triangle because with Pythagorean theorem, it only applies to right triangles. So Jesse and Kyle are at the same location. Jesse is going to go north and Kyle is going to go east. So let's just say they start here and then Jesse goes north to here, and that is 12 meters, while Kyle goes east, which is 18 meters. So the shortest distance between each other is going to be from here to here, which is going to represent the hypotenuse. So we have A is going to be 12, B is 18. So remember, the Pythagorean theorem says the legs squared added together is going to be equal to the square of the hypotenuse. So one leg is 12, the other leg is 18, and we're finding the hypotenuse. So we square each leg, then we're going to add these together. This gives us 468. Then we're going to undo c squared. We're going to take the square root. And so the distance is not going to be an exact number. So we're going to estimate, and we're just going to use our calculator and take the square root of 468. And we get about 21.6. So let's always just round to the 10th. So they are 21.6 meters apart. The 18-foot tree casts a shadow of, that should say of, 24 feet. So we have a tree, trees are standing, and the shadow, which is on the ground, shadows are on the ground, is 24 feet. So these are our legs. How far is the base of the tree to the end of the shadow? That really should say how far is the top of the tree right here to the end of the shadow. So again, we're finding the hypotenuse. So A equals 18 this time and B equals 24. So we have 18 squared plus 24 squared equals c squared. We're going to add these together. We're going to undo the squaring by taking the square root, and c is 30 feet. A ladder leans against a 24-foot building. So we have a ladder that's leaning. The building is 24 feet. From the base of the building to the base of the ladder is 7 feet. How tall is the ladder? So again, we're looking for the hypotenuse. Add these together. Take the square root, and the ladder is 25 feet. Beth made her granddaughter a rectangular quilt that measured 6 by 8. So let's make a quilt, rectangle. It is 6 by 8. She sewed a ribbon from the top right corner to the bottom left corner. How long is the ribbon? So we're looking for the hypotenuse. The diagonal of a square or a rectangle is always the hypotenuse. So we have a leg of 6, a leg of 8. We're finding the diagonal. And the diagonal, the ribbon is 10 feet long. Okay, now let's take a look at a three-dimensional Pythagorean theorem. We're going to determine the longest length of a rectangular prism. So we're looking inside. So the longest length inside of a rectangular prism is from the top of one corner all the way down to the opposite bottom corner. So instead of having 2 legs, we're going to have 3 legs, A, B, and C. And this length, D, our diagonal from the back top to the front bottom, is going to be the longest length inside of this box. So we're going to plug in 8 for one leg, 4 for another leg, and our third dimension, 12 for the other leg, to find the longest distance of D squared. And we're going to add these together. And we get a sum of 224. And then we're going to take the square root, and that distance is going to be about, it says 14.9666629 and so forth. So I don't want to round this to a 15. So I'm going to round to the hundredths this time. And that is going to be the longest distance inside that container. Let's try another one. We have legs 12, 9, and 15. And we're going to square each of these legs. We're going to add them together and then take the square root. And that gives us a total of 450. And then we take the square root and we get about 21.2. And it's just about, so that's the longest distance. I hope this helps.